Okay, so a quick review of what we've covered so far in math at the beginning of the year in Unit 1. I wanted to start out with absolute value. Absolute value is just distance from 0 on a number line. However many spaces from 0 it is its absolute value. So, change my color here. So if I'm looking for the absolute value of -8, and again, these right here are absolute value markers. They just mean absolute value. So if I'm talking about the absolute value of -8, well, -8's 8 spaces from 0. The absolute value of -8 equals 8. Absolute value is all about distance from 0, and when I say distance is always positive. No such thing as a negative distance. They do not exist. So when we're calculating absolute value, that's what we're talking about. So let's set up a problem here. I've just got me some absolute value bars down here ready to go. So if I wanted to find the absolute value of, I'll go ahead and stick with my -8, and I want to add it to the absolute value of 2. The first thing that we do here is we calculate the absolute values. The absolute value of -8 is 8. The absolute value of 2 is 2. 8 plus 2 is 10. So that's how stuff like that works. Anytime you see absolute value in a problem, those are considered grouping symbols, and in the order of operations, we use what's called GEMDAS. We used to call it PEMDAS with the P here, but we've actually tried to change that to G because there's lots of different kinds of grouping symbols that we use. A new one this year for my 7th grade students are these absolute value bars here. So we do grouping symbols first, and this is how absolute value works. Distance from 0, always positive. The next thing we've looked at is adding integers. And so I'm just going to throw up a little addition sentence here, and I'm going to show how we've modeled it using these counters. Because the way that we've modeled it this year is these yellow are going to represent positive numbers, and these red ones are going to represent negative numbers. So if I wanted to do something like -2 plus 3, I can show that using these positive and negative counters down here. So I'm going to represent this -2 like so. And I'm going to represent this positive 3 that I'm adding to it like so. And what we've talked about so far is anytime you have a positive and a negative together like this, they represent what's called a neutral pair, or a zero pair. A -1 and a +1 cancel each other out. In this particular problem, we are left with one positive, so that's our answer. Pretty cool. Let's show another one real quick. Oops, don't want to do that. So let's show one where we have some negative numbers. Let's add a -2 plus a -4. Now the last one we were adding positives and negatives, and those created zero pairs. In this scenario, I'm just adding negatives to negatives. So I'm going to show my -1, 2, and my -4. 3, 4. The most common mistake that my guys make in class is they want to start trying to cancel out zero pairs. But when you have a negative and a negative, they do not cancel each other out. Anytime you're adding things with the same sign, when they're both negative, like in this example, you just keep them all. You add them together, and you keep that negative sign. I've got 1, 2, 1, 2, 3, 4, 5, 6 negatives. And that is my answer on this one, negative 6. We've been doing this with positives since, maybe kindergarten or first grade. If this were a 2 and this were a 4, I would have all yellow out here, and I would keep them all, and we know that 2 plus 4 is 6. Same thing with the negatives. When they're both negative, you just add them and keep the sign. But let's talk about some of the specific rules when we're dealing with this stuff. When the signs are the same, and this is what I just said, when the signs are the same, we add them. And keep the sign. So that looks like whenever we're, and I'll just show it again. This is like the 4 plus 2 equals 6, but also negative 4 plus negative 2 equals negative 6. When the signs are the same, both positive or both negative, you add them and keep the sign. On the other example here, when the signs are different, we do something different. We subtract. Here's where it gets just a little tricky, but it's not so bad. After we subtract, we keep the sign of the add-end. Oh, well, what's an add-end, Mr. Millwood? An add-end are just the things that you're adding in a math problem. The 4 and the 2 are the two add-ins in this problem, and we call our answer to a math problem the sum. So whichever add-end has the greater absolute value, and that's what we talked about at the very beginning of this video, absolute value, key concept in this section. And so let's talk about what this looks like real quick. Now I'm adding when the signs are different. So I'm going to have different signs, and that looks like this. Let's say negative 2 plus 5. So my signs are different, so I'm going to subtract. Now I'm going to subtract, and really I'm going to subtract their absolute values. What is 5 minus 2? Well, that's 3. My add-end with the greater absolute value is actually my positive add-end. My negative add-end is only 2 spaces from 0. My positive add-end is 5 spaces from 0. Their absolute values are 2 and 5. So whenever I subtract these two, I'm going to get 3. My add-in with the greater absolute value is my positive, so my answer is positive. Let's show one where my greater absolute value for my add-in is negative. Let's say I've got 6 plus negative 7. Well, I'm going to do the same thing. My signs are different, so I'm going to subtract. 7 minus 6 does equal 1. So I'm going to keep the sign now with the add-in with the greater absolute value. This is 7 spaces from 0, whereas this is 6. This has a greater absolute value. It's my negative add-in, so my answer is negative 1. Now we're going to talk about subtracting integers. Oh, I've got a typo up here. This should definitely be integers. Put a G in there. What's up, G? All right. Subtracting integers. And that almost looks like a 9. Okay, I'm just going to... Students are laughing at me behind me. Integers. Yeah, pretend none of this happened. Okay, subtracting integers, we use keep, change, switch. And so from now on, whenever I refer to that in class, I'm just going to use the first letter of them there, keep, change, switch. And so the nice thing about this is it just changes it back into an addition sentence. So if I have negative 4 and I'm subtracting 2, I can use keep, change, switch just to make this an addition sentence again. My keep is negative 4. I'm just going to rewrite it right below it. My change is going to be changing it from subtraction to addition. My switch will make this 2 and negative 2. This is just what I dealt with before whenever I was adding integers with the same sign. When the sign is the same, in this case they're both negative, my answer is going to be negative, and I just add the values. So subtracting integers is much like adding integers once you use keep, change, switch. All the same rules apply. Let's look at another one. So let me see, that was one where I used 2. On this one I'll say, let me see, 2 minus negative 5. So I'm going to use my keep, change, switch. My keep is going to be 2. My change will make this a plus. My switch will make this negative 5 a positive 5. Oh, nice. This one just changes to 2 plus 5. Nice and easy, right? And one more example showing the keep, change, switch to make this an addition problem. Let's say I have 6 minus 10. Well, it looks like I'm trying to take away more than I have over here. So it looks like my answer will be negative, but let's go ahead and use the keep, change, switch to make this an addition problem. This will be keep, change, switch. So my signs are different here. This is where, and I'm just going to click back to the previous screen real quick. When the signs are different, I subtract and keep the sign of the add-in with the greater absolute value. So I'm going to subtract. 10 minus 6 is 4. And I'm going to keep the sign of my add-in with the greater absolute value. My negative number is farther from 0. My answer is negative.